Welcome to this lesson. This is our first lesson in the topic integration. So we are going to look at what is integration. Earlier on you have covered topic known as differentiation. Differentiation is when you get the gradient function of a given function, that is gradient function. So integration is the reverse of differentiation. This is to mean that if you are given the gradient function, to get the function itself, you integrate. Here we have an example. We have three functions or equations. So this is the first one, y is equals to x plus 2. Then we have y is equals to x plus 3. And y is equals to x plus 2. So let's have a look at the graphs that can be obtained from these functions, and then you see the kind of graphs they are and how they are related. So this is a graph that we obtained from the equations given. So this is the graph of y is equals to x plus 3. This is a graph of y is equals to x plus 1, and this is a graph of y is equals to x plus minus 2. You observe that the three lines are parallel, and we know that parallel lines have the same gradient. So when you use the differentiation, we start with the first one, and that is y is equals to x plus 3. Then the gradient function dy over dx is equals to 1. Then we have y is equals to x plus 1. Then we have dy over dx, that is the gradient of this line, is the same as 1. Then we have y is equals to x minus 2. We get dy over dx is equals to 1. So we find that all the three lines have the same gradient, but the y-intercept is different. This one crosses the y-axis at 3. This one y-intercept is 1, and this one y-intercept is 2. So we can conclude that all the functions have the same gradient, that is 1, but y-intercept is different. So let's see how now we reverse this, get the reverse, that is we integrate this gradient and get the functions themselves. Therefore, an equation whose gradient is 1 is written in the form of y is equals to x plus c. This is because we have seen that c can take any value which we refer to as the y-intercept. But as long as the gradient is 1, then the equation will be of that form. Integration, therefore, is a process of finding the function given the gradient function using the method that follows. So if you are given a gradient function, to get the function, let's say take an example that our gradient function is dy over dx is equals to xn. Then the function y is equals to, we add 1 to the index, that is n. We divide with the new power or index, and then we add c, where c we have said is called an arbitrary constant, and n should not be equals to minus 1. So this is the method that we are going to use to do integration when we have been given the gradient function. For example, in our example, if we are given previous example, dy over dx is equals to 1, then the gradient, the function is, okay, we can say y is equals to, this is, we can say it is x to power 0, so we can write 1 x to power 0 0 plus 1, and then we divide by 0 plus 1, that is, we are applying this method, this formula, then we add to c. So 1 times x to power 0 plus 1, we will get our y is equals to x. Then we'll divide by 1, it remains the same, and then plus c. So let's do a few more examples and see how this method is applied. You can advertise here. Just call us on 0725 35 7594. Thank you. Our example 1, integrate the following: a x squared, b x cubed plus 3x squared plus x plus 1. So what this means, we start with a, is that dy over dx is equals to x squared. So that is the gradient function that we have been given. So if we were to integrate, then to integrate is to get the function, and we have said that to get the function given the gradient function, we say you take x, n plus 1 divide by n plus 1 plus c. So this means that since here we have x squared, then our function y is equals to x 2 plus 1 divided by 2 plus 1 then plus c, implying that our y is equals to, now here we will have x to power 3 or x cubed divided by 3 plus c. So this is a function that was differentiated for us to get the gradient function x squared. We go to part B. So this means dy over dx is equals to x cubed plus 3x squared plus x plus 1. So this means to get the function using the same method, we say y is equals to, we add 1 to 3, so this will be x 3 plus 1 divided by 3 plus 1. We come to the second term, this is 3 x 2 plus 1 divided by 2 plus 1, then plus, this is x to power 1, so it will be x 1 plus 1 divided by 1 plus 1 plus, here when it is 1, then it means x is to power 0, which is the same as 1. So we get plus x, that is 1x 0 plus 1 divided by 0 plus 1, then finally we add the arbitrary constant. So this will give us the function y is equals to, this will be x to power 4 divided by 4, so we have x to power 4 divided by 4. The second term is 3x cubed divided by 2 plus 1 is 3, so this 3 and this 3 and this 3 will cancel, so we will be left with plus x cubed Then here we have 1 plus 1 is 2, so we have plus x squared divided by 2. This will be x to power 1 divided by 1, so we will have our x, and finally we have the arbitrary constant. So that is a function which was differentiated for us to end up with this function. So that is how you integrate these functions. To get complete DVD of this topic and other topic, call us on 0725 35 7594. Our example 2a, we integrate 2x. So this, when you are taught to integrate, what this means is that this is a gradient function, i.e. dy over dx is equals to 2x. And we have said for us to get the function, then we write y is equals to 2x. We add 1 to the index of our x, so 1 plus 1, divide by the new index, which is 1 plus 1, then we add to the arbitrary constant. This means that our y is equals to, this is 2x, 1 plus 1 is 2, so it is x squared divided by 2 plus c. So we can divide 2 by 2, we get 1. So we are left with y is equals to x squared, this is plus c, not 1, x squared plus c. So that is a function which was differentiated to get 2x. So that's how you integrate. So integrate the following, that is x to power minus 4. So what this means, that the gradient function dy over dx is equals to x to power minus 4. So to integrate this, then we say our y is equals to x minus 4 plus 1 divided by the new index minus 4 plus 1, and we add to the constant. So from there we say this is y is equals to x minus 4 plus 1, that you get minus 3, divided by minus 4 plus 1, you get minus 3 plus c, which we can write now as y is equals to minus a third x to power minus 3 plus c. Or in another way, we can say this is minus a third x cubed, because of the negative index, it is an inverse, plus c. So that is how you integrate that gradient function. So in this example, we integrate the following: 8x raised to power 3 minus 3x raised to power minus 2 plus 3x plus 1. So this means our dy over dx is equals to 8x cubed minus 3x to power minus 2 plus 3x plus 1. So we are required to get the function which was differentiated to get this gradient function. So it means our y is equals to 8x 3 plus 1. We divide with the new index, which is 3 plus 1 minus 3x, this minus 2 plus 1. We divide with the new index, this minus 2 plus 1, and then we have plus 3 x raised to power 1. So we add 1, we divide by 1 plus 1 plus, here we say it is, when it is a constant, x is to power 0. So we write 1 x 0 plus 1 0 plus 1 0 plus 1 plus a constant. So when you compute this, you find this is, the denominator here is 4, so we have our y is equals to, so 4, we divide 8 by 4, we get 2, x 3 plus 1, we get 4, minus, here it is minus 2 plus 1, we get minus 1. So this minus changes to positive because of that minus. So we have 3x. This is minus 2 plus 1. So we get minus 1 plus, this is, the denominator is 2. So we have 3 over 2. Then we have x. 1 plus 1 is 2. Then we have plus 1. This will be 0 plus 1. To be x to power 1 plus c. So that is a function which was differentiated to get this gradient function. So in this example, we integrate a gradient function 2x to power 4 minus 2 divided by x squared plus 1. So in this case, we first of all factor out 2. So you have 2 into bracket x to power 4 minus 1 close a bracket. This is divided by x plus 1, x squared. Now we can factor, write the numerator, expand it further using the rule of a difference of two squares. So we have 2 into bracket. This can be written as x squared minus 1 close a bracket and x squared plus 1. This is divided by x squared plus 1. So we can now divide x squared plus 1 and you get 1. So when you expand the other part, you find that 2x squared and then minus 2. So this is, we can say this is our dy over dx, what we are supposed to integrate. So the function that was differentiated to get this gradient function is 2. Now, once you get used, you don't need to write plus 1. So you write it is x raised to power 3 divided by 3 minus 2x plus c. So this is our gradient function, which is y is equals to 2 over 3 x cubed minus 2x plus c. So that is the answer to that problem. So in this example, find y given that dy over dx is x plus 2 into bracket squared. So the first thing is to expand this. So we say this is x plus 2 into bracket x plus 2. So we multiply x multiplied by x, we get x squared plus x multiplied by 2, we get 2x. 2 multiplied by x, we get 2x. And 2 multiplied by 2, we get plus 4. So this we write x squared plus 4x plus 4. This implies that our dy over dx is equals to 2x is equals to our dy over dx is equals to x squared plus 4x plus 4. Then we get our y, that is we integrate. So y is equals to, So we get y. We integrate this gradient function. So our y is equals to x to power 3 divided by 3 plus 4x squared divided by 2 plus 4x divided by 1 plus c. So when you simplify this, you get y is equals to a third x cubed. Here we divide 4 by 2, we get 2, so it is plus 2x squared plus 4x plus c. So that is how you integrate to get the function from the gradient function x plus 2 into bracket squared. So in this example, we are supposed to find y given that dy dx is into bracket 2 plus x squared into bracket 2 minus x squared. So we first of all expand the numerator. So you have 2 times 2 is 4. 2 times minus 2x squared is 2x squared. Then we have x squared multiplied by 2 is plus 2x squared. Then we have x squared multiplied by minus x squared. We will get x to power 4. This is divided by x squared. So we can see here that 2x squared will cancel with 2x squared. That is, you subtract, you get 0. So we'll be left with 4 minus x to power 4. All this is divided by x squared. From there, then we can simplify and say this is 4 divided by x squared minus x to power 4 divided by x squared, which we can write like this: 4 over x squared minus, now here x squared to x to power 4 will be divide each other and we have 2 there, so we have x squared. Then we can now have this is the same as 4x to power minus 2 minus x squared. So this is our dy over dx after we simplify the gradient function given here. Now to get our y, it is equals to 4x minus 2 plus 1, you get minus 1, you divide by minus 1, minus, this will be x, 2 plus 1 you get 3, divide by 3 plus c. And therefore our function that we'll get after integrating is y is equals to, this now will be minus 4 x to power minus 1 minus x cubed divided by 3 and plus the arbitrary constant. So that is how you get the function when given dy over dx is that. So in this example, find y given that dy over dx is 2 square root of x plus 2x minus 1. So 2, the root of x, we can write it like this: 2 x is the same as x raised to power 2 half, then plus 2x minus 1. So this is our dy. This implies that dy over dx is equals to 2x raised to a half plus 2x minus 1. So having that, now we can get the gradient function, which is y is equals to, now it is 2 we add 1 to a half, so it's a half plus 2, which will be 3 over 2. That is x divided by 3 over 2. Then we go to plus 2 x squared divided by 2 minus 1 will be x raised to power 1 divided by 1. It remains x plus c. So when you simplify this, you will be able to get y is equals to 2 divided by 3 over 2 will be 4 over 3 x raised to power 3 over 2, and then we have my plus this 2 cancels with that, so we have 1, so we'll be left with x squared. Then we have minus x plus c. So finally, after integrating, our y is equals to 4 over 3 x raised to power 3 over 2 plus x squared minus x plus c. So that is how you get, or you integrate, or you get the function y. So when looking for the function, given the gradient function, we have been using a c, putting a c, which we called an arbitrary constant. We can find c if we are given more information, and we are going to do that by use of this example 4. So it says find the equation of the curve whose gradient function is x plus 1 and passes through point 2, 1. So this means that our dy over dx is equals to x plus 1. So we can get our y by integrating this. So we get y is equals to x squared divided by 2 plus x plus c. Now we want to find c. We are told that this gradient function passes through 2, 1. So we have this is one of the point of the curve, so we can replace the value of y, which is 1, and the value of x, and by doing that we will be able to get our c. So y is 1 is equals to x is 2, so we have 2 squared divided by 2 plus 2 plus c. So 1 is equals to, this is 4, 4 divided by 4 is 2, 2 plus 2 is 4 plus c. So we take 4 to the other side, we have c is equals to 1 minus 4, which is equals to 3. This means that our c is equals to minus 3. Therefore, we can now be able to write the equation and say y is equals to a half x squared. Then we have our x plus x, and now we have obtained our c, which is minus 3. So we can get the value of c given more information. For example, in this case, we have told that the curve passes at 2.21. So in example 5, find s in terms of t if ds over dt is equals to 4t cubed plus 2t plus 1, given that s is equals to 2 when t is equals to 1. So in this case also, we will be able to find our constant c, because we have been given some extra information of s is equals to 2 and t is equals to 1. So we integrate this s, so that in terms of t, so you have our s is equals to, this is 4 t to power 4 divide by the new index 4 plus 2t squared over 2 plus t plus c. So that is the integration of this gradient function. We can simplify, so we can divide 4 by 4, we get 1. Divide 2 by 2, we get 1. So our s is equals to t to power 4 plus t squared plus t plus c. Now that we have been given s is equals to 2 when t is equals to 1, we replace it in our function so that we get the value of c. So s is 2, so 2 is equals to 1 to power 4 plus 1 squared plus 1 plus c. So this will give us 2 is equals to 1 to power 4 is 1, 1 squared is 1, and we add 1, so that is 3. So it is 3 plus c. We take 3 to the other side, becomes negative, and therefore our c is equals to 2 minus 3, which will give us minus 1. Having found the value of c, we can now be able to express s in terms of t. We say s is equals to, now we come here and say t to power 4 plus t squared plus t minus 1. So that is how you express s in terms of t. Are you a teacher and would like to produce your own DVD in your area of specialization? Contact us on 0725 35 75 94 and make extra income. Get complete DVD of this topic and other topic, call us on 0725 35 75 94. This is Teacher Wamta Productions. Mobile number appearing on your screen, my email address, and you can visit my YouTube channel Teacher Wamta for more topics and revision.